Hello, we're back. I'm Wim. Of course,
I'm Stuart.
Stuart and Wim here. We are recording this little overview of Chapter 2. It's the electromagnetic radiation principles, and it's an exciting chapter that you have to go through, and we'll be kind of covering a few things right now to kind of give you the highlights that we think are important. Stuart has been teaching this class many, many times, so I mean he's really the expert here on this book, right?
It's been a lot of years, as I mentioned in the introduction, and this is really the foundation for everything you're going to do in the rest of the course. You really need to understand the electromagnetic spectrum, different regions of the spectrum, what we use each region for. So it's really an important foundation.
Yeah, the electromagnetic spectrum and the information you get from it, it's basically everything is the electromagnetic spectrum. All the information you're going to get in this course is related to the electromagnetic spectrum. So you're really, if you understand this chapter, you're basically laying the basis for a lot of the applications and the other chapters. So in terms of what we're going to cover here, I mean, you're going to see where all the radiation that's coming from the sun is really hot, so it's actually going to emit energy at, because it's 6,000 degrees Kelvin, it's emitting all this energy mostly in the visible spectrum, and that's why we see a lot of light here on Earth, because the sun is so hot and it's emitting mostly in the visible spectrum. It goes all the way out to the shortwave infrared, but then you're basically going to trail off and not see too much in the other parts of the electromagnetic spectrum, like in the microwave and the thermal region. It's actually the Earth itself that's going to be emitting radiation in the thermal region a lot because it's much cooler, and it's actually the majority of radiation that's being emitted by the Earth is actually in the thermal region, while for the sun, because it's so hot, it's going to be emitting mostly in the visible region. So as the radiation is coming from the sun, it's going through vacuum space basically. It travels at the speed of light, and as it reaches the Earth's surface, it's going to interact first with the atmosphere, to start to scatter there, and then as it goes through the atmosphere, it's going to reach the Earth's surface. The Earth's surface is also, of course, then interacting with that radiation. Then, of course, for the satellite to measure it, it has to go back up. And as it goes back through the atmosphere, and again, it goes through a little bit of space, basically vacuum, and it reaches the sensor. And the sensor then records that energy and that radiation that's coming from the sun, basically. So those are most of the sensors in terms of, they use the sunlight as a source of energy to record and what the Earth is reflecting back.
And when you're looking at the chapter, you'll learn some things about what happens in the atmosphere that will be really important. You'll learn about the types of scattering that's taking place and what regions of the atmosphere it's taking place in. You'll be able to answer the question why the sky is blue when you're done with the chapter, why clouds appear white, and why we have, particularly in Tucson, these nice red sunsets.
And so other things that there's a few equations in the chapter that you might want to get familiar with that relate to how much energy is being emitted. So that's a Stefan-Boltzmann law, the law that allows you to compute what wavelengths the most radiation is coming back from the sun, for instance. The Wien's displacement law allows you to do that in terms of what the dominant wavelength is. I think it will allow you to start looking at some of these absorption, scattering, and transmittance properties of the atmosphere, and as well as on the Earth's surface. So radiation basically gets transmitted, it gets reflected, and it gets basically absorbed. And it basically that is basically the
It's something
issue with both the
right.
surface and the atmosphere. So.
That's right, and it's something you already know, because if you're out hiking on a warm day and you have two rocks to decide to sit down on, most likely you're going to decide to sit down on the one that's very bright. rather than a really dark rock, because you know that one's going to be a lot cooler than the really dark rock. So you already know something about energy being absorbed versus reflected. And we're just going to take that in a little bit more detail to understand what those properties are.
So you're going to learn a little bit more about the radiometric terms that we use as the energy that's coming from the sun. We call quite often irradiant, and the energy that's being reflected we call radiant. So you're going to get familiar with some of those terms. You're going to get a little bit more familiar with the different atmospheric windows, as we call them, where we can use windows as the atmosphere is a window. We have windows in buildings. We can see through them. So sensors, satellites, sensors basically, the sensor can see through the atmosphere and actually record things that are on the Earth's surface. So, and that's going to be governed by molecules and particles in the atmosphere. And we're going to look at Rayleigh scattering and Mie scattering, non-selective scattering, things that are happening in the atmosphere, and how we can actually deal with those, and how different wave bands, as we call them, different parts of electromagnetic spectrum, how they actually can be used to record different characteristics of the Earth's surface. So I think that's in general what this chapter is all about.
Things, and don't be intimidated by the equations. And I think you'll learn some very practical things as you go through the chapter.
Yeah, so you're going to do again the reading quiz. Like every unit, you're going to have a reading quiz. You're going to have an activity associated with that, maybe a discussion forum as well this week. And so hopefully start early. Don't make it the last, do it at the last minute, but really start early, and so we can actually help you if you have any questions. I think that's it for this week, and we see you back next week, and please feel free to ask us any questions.